Hi everyone. Today we will be completing our notes on the zero and the negative exponent. To begin, I want to take a look at the Inspire activity called Exploring Exponents. If you're following along with me in class, I've distributed this program to each of you, but if you're following along at home, you can just follow along with the video. We'll start with page 1-1, which explains the activity. We're exploring exponents, particularly the zero and negative exponents. If we hit Control and to the right, we'll move to page 1-2. We know that exponents generally count the number of times the base is to be a factor. So for example, 4 cubed, or 4 raised to the third power, is equal to 4 times itself 3 times, or 4 times 4 times 4. But what happens if the exponent is negative? It doesn't quite make a whole lot of conceptual sense to multiply something by itself a negative number of times. So on the next page, we're going to explore what this means. So here we have 2 to the power, and we have 3 to a power. And we're going to use this slider here on the bottom to evaluate 2 to the x and 3 to the x. We're going to fill in the chart. So beginning with x equals -6, I'm going to click the slider all the way to x equals -6 and record these values. 2 to the -6 is approximately equal to 0.016, and 3 to the -6 is approximately equal to 0.001. So let's go ahead and fill in our table. Let's go ahead and evaluate for x equals -2. So using the slider, I'm going to go over to x equals -2, and evaluating 2 to the x and 3 to the x, we have 2 to the -2 is 0.25, and 3 to the -2 is 0.111. Let's go ahead and fill in the table. Now evaluating for x equals -1, 2 to the -1 is 0.5, 3 to the -1 is 0.333. All right. Evaluating x equals 0, so 2 to the 0 is equal to 1. Likewise, so is 3 to the 0, equal to 1. If we plug in 1, well, now we're back into positive exponents. We should actually be able to evaluate these on our own. 2 to the 1 is 2. 3 to the 1 is 3. And evaluating x equals 3, we have 2 to the 3 is equal to 8. 3 to the 3 equals 27. And finally, evaluating x equals 4. 2 to the 4th power is 16. 3 to the 4th power is 81. Okay. So you might notice a pattern. Number 2, as the value of the exponent increases, what do the values of 2 to the x and 3 to the x, do they increase or decrease? So as we move down in our table, as these x values increase, what happens to our 2 to the x and 3 to the x values? Well, they also increase. And likewise, when the value of our exponent, or as the value of x decreases, the value of 2 to x and 3 to the x also decreases. Number 4, what is the value of both expressions when the exponent is 0? When x is equal to 0, or the exponent, both values, 2 to the x and 3 to the x, is equal to 1. And the second question, do you think that all numbers raised to the 0 power will be the same? What do you think? I think so. When the exponents are negative, are the values of 2 to the x and 3 to the x negative or positive? Contrary to what many students might think, the negative exponent does not make the value negative. It's positive. So because a negative exponent leads to a positive value, does it seem that a negative exponent makes the value of an expression negative? No, it does not appear that a negative exponent makes the value of an expression negative. All right, so let's explore the zero exponent on the following page. We can say that for all real numbers a, So a can be any number. A to the 0 power, or any number to the 0 power, is equal to 1. Therefore, 96 to the 0 power is equal to 1. The reason, well, we know that if we take something like x to the 4th divided by x to the 4th, well, from our last video, our last notes, we learned the quotient rule. We subtract those powers. Okay. We also know that any number over itself, or any quantity over itself, is just 1. We're dividing something by itself. And then again, we know from our last notes that the quotient rule states that we subtract the powers. So x to the 4 minus 4 is equal to x to the 0. So we know that x to the 0 is equal to 1. Let's try these without a calculator. 4 elevenths to the 0, that's equal to 1. That works on fractions. Negative 3 all raised to the 0, also equal to 1. Works on negative numbers. 2xy all raised to the 0 is also equal to 1. Now, we always have to be careful when raising powers to 0, because we have to see what exactly are we raising to 0. What's the base of my exponent? Okay, so if we're raising that whole base, raised to the 0 power turns into a 1. Now let's explore negative exponents. So let's go ahead and use the inspire to evaluate each of these here. So we'll start with the left-hand column. So I'm going to exit out of this program. I'll start a new document, and I'm not going to save this. And then I'll go to calculator, and I'm just going to go ahead and evaluate like 2 to the 1. So I'm going to hit 2 to the first power is equal to 2. 2 squared. And I'm going to use the shorthand key. So this key right here is the x squared key. Instead of going up in the exponent, is equal to 4. 2 cubed. So 2 to the power 3 is equal to 8. And now let's try it with a variable. So x to the first power. So x to the first power is equal to just x. X squared. I'm going to use that squared key, is equal to x squared. You guessed it. And x cubed. You could probably guess this one too, huh? X to the third power is x to the third power. There's no way to simplify this expression. Now let's try with negative exponents. So we're going to do the same thing, but now in the exponent, I'm going to plug in negative 1. So 2 to the negative 1. And I'm going to use this negative key here. Note that this is different from the subtraction key. We're going to use the negative key, which is next to the decimal point. So 2 to the negative 1 is equal to 1/2. 2 to the negative 2. So we'll do that. 2 to the power negative key 2 is 1/4. 2 to the negative third, so 2 exponent negative key 3 is equal to 1/8. X to the negative first power, so x to the negative first is equal to 1 over x. X to the negative 2, so x to the negative 2 is equal to 1 over x squared. And finally, x to the negative 3, we get 1 over x cubed. Oops, 1 over x cubed. There we go. So take a look at these columns and see, what do you notice about these columns? What's similar about them and what's different about them? Well, I noticed that both of these columns contain the same numbers or expressions. That's what they have in common. Both contain the same numbers or expressions. So like all of our raised to the power 2 or negative 2, they have 4s in them, or to the 3, 2 to the 3 or 2 to the negative 3 have 8s in them, right? Same thing with our variable bases. So x to the third, we have x cubed, and we've got an x cubed over here. It's just 1 over x cubed. So the thing that I noticed that's different is that the right-hand column contains fractions. And notice that the right-hand column is all of our negative exponents. So for negative exponents, all of these quantities are fractions. So let's take a look at what this means in general. For all real numbers a, b, and n, where b is not equal to 0, a to the negative n is equal to 1 over a to the positive n, or the quantity 1 over a, all raised to the power of positive n. So for example, 1 over 9 fifths, 9 to the negative 5 is equal to 1 over 9 to the fifth. There we go. And actually, let's go ahead and evaluate that. That's probably going to be a very large denominator. 9 to the fifth, yeah, is 59,049. So let's go ahead and write that. That's equal to 1 over 59,049. And the reason is, well, if we start off with our quotient rule, so we know that x to the third, just as an example, over x to the fifth is equal to x to the 3 minus 5, or x to the negative 2. We also know that if we were to expand these out, x to the third over x to the fifth, that would be equal to x times x times x over x times x times x times x times x. I'm expanding those exponents as repeated multiplication. Well, I noticed that we can cancel out factors in both the numerator and denominator. We can cancel out a pair of x's, two pairs of x's, three pairs of x's, and that's all we can cancel out. And we have two x's left in the denominator. So this evaluates to, or simplifies to, 1 over x squared. So we can see that x to the negative 2 is equal to 1 over x squared. Let's consider a over b, all raised to the negative n. This is equal to the quantity b over a raised to the positive n. And so this is why b cannot be equal to 0 in the definition. Because if b is equal to 0, that would cause this denominator to be equal to 0, causing this quantity to be undefined. So b cannot be equal to 0. So let's try 5/6 raised to the negative 2. This is equal to 6/5, the reciprocal, raised to the positive 2. Or 6 squared over 5 squared. You can distribute that power to both the numerator and denominator. We learned that yesterday with our power rule. And then 6 squared in the numerator is 36. 5 squared in the denominator is 25. And that's our answer. Finally, in summary, a negative exponent means the reciprocal of the base. So take the reciprocal of the base and then raise it to the positive power. All right. So that concludes our notes today on the negative and the 0 exponent. I hope you learned a lot. We'll get a lot of practice, so I'll see you tomorrow. Have a great day, everybody. Goodbye.